Before we jump into today's story, go ahead and subscribe to In the Beginning, so you never miss these forgotten techniques that helped people survive extremes long before modern gear existed. Because what you're about to learn isn't a gimmick or a novelty. It's a tested solution from World War II that kept soldiers, medics and field engineers safe in conditions that would have shredded standard tents. For the first minute, just imagine a wind-swept hill in northern Europe during late winter, gusts hitting over 90 miles per hour and flimsy canvas shelters collapsing within seconds. Soldiers needed something stronger, faster and, well, smarter than conventional tents. They didn't have the luxury of windbreaks, tarps or prefab structures. What they did have was ingenuity and a simple staking method that turned ordinary poles and ropes into virtually storm-proof shelters. So, the principle behind the World War II stake trick begins with understanding the limitations of traditional tents. You see, canvas tents rely on tension and poles to maintain their shape. In high winds, that tension shifts unpredictably, poles bend, and the fabric slaps violently, weakening the anchor points. Even reinforced pegs can pull free if the wind hits at an angle, or, the soil is soft. Field reports from 1940s military archives describe entire encampments flattened overnight, soldiers soaked and exposed, and equipment damaged. The solution had to address not just vertical uplift, but lateral drag. This is where the staking technique comes in. Strategically angled, deeply driven stakes combined with cross-bracing transformed a simple tent into a resilient structure capable of withstanding hurricane-force gusts. The strength of the method lies in triangulation and load distribution. Instead of placing stakes perpendicular to the ground directly under corners, soldiers angled them outward at 45 degrees and used multiple ropes to connect them to the tent's corners and midpoint seams. Each rope created a line of tension that shared the load across several anchor points. When wind hit one side, the force wasn't concentrated at a single peg. It was distributed through the network of lines and stakes. The tent maintained its shape because each anchor reinforced the others. In modern terms, it's like turning a soft, bendable shelter into a geodesic framework without changing the canvas itself. For anyone camping in high-wind areas today, this method instantly increases stability without needing specialized poles or heavy-duty stakes. Another critical element is stake depth and material. World War II manuals emphasized long, sharpened wooden stakes or rebar driven deep into firm soil, often at least a foot underground. Soldiers learned to inspect the soil for soft spots and reinforce those areas by placing a second stake nearby and linking the ropes together. In sandy or loose ground, they would use a deadman anchor, burying a log horizontally and tying the rope over it, effectively creating a buried anchor that resists pull-out far better than a vertical stake alone. These simple additions allowed even lightweight canvas to withstand wind speeds that would normally tear holes or collapse poles instantly. The rope system itself was part of the ingenuity. Instead of one continuous line, soldiers often use shorter lengths with secondary knots, hooks and loops to adjust tension quickly. This allowed real-time corrections during storms. If a gust pulled the tent forward, a quick adjustment of one rope or anchor point redistributed tension across the entire structure. Modern campers can replicate this using paracord and small tensioners. The principle is identical, you know. Don't rely on a single point of contact. Create a dynamic network that flexes and absorbs stress. Practical application today requires observing the same principles in modern conditions. First, choose a site with firm soil, ideally slightly sheltered by natural windbreaks like rocks or trees. Drive your stakes at an outward angle and ensure they are deep enough to resist pull-out. Use multiple ropes connecting corners and midpoints, adjusting each until the canvas or tarp is taut but not overstretched. For extreme conditions, bury secondary anchors or logs as deadman points to stabilize loose soil. The beauty of this method is that it works with tents, tarps, temporary shelters, and even lightweight cabins. One example from the archives illustrates just how effective this method could be. A forward medic unit stationed near the North Sea in 1943 reported that their standard-issue tents survived a 90-mile-per-hour storm overnight. Now, adjacent units using conventional staking actually lost half their shelters. The difference wasn't new canvas or heavier poles, it was, in fact, the stake technique. By analyzing wind vectors, soil quality and anchor placement, these soldiers applied a principle that, well, combines geometry and physics, resulting in a shelter that flexed without tearing. That same principle can be applied today for festival camping, mountaineering base camps, or survival scenarios where stormproofing is, absolutely critical. The lesson from this technique is broader than just staking tents. It teaches us to observe forces, anticipate failure points, and create redundancies. Every anchor, rope and tension line in the World War II method functioned together. Nothing acted alone. Survival often depends on simple, repeatable systems working in harmony rather than relying on one hero solution. For anyone interested in historical survival methods, engineering hacks, or low-tech resilience, studying these field-tested tricks gives you a tangible advantage. By learning from these archives and experimenting with your own applications, you not only gain practical skills, but also a connection to the ingenuity of soldiers who survived extreme conditions with limited resources. If you found this guide valuable, subscribe to In the Beginning and share it with fellow history and survival enthusiasts. Preserving these techniques ensures that the wisdom that kept people alive during one of the most intense periods in modern history isn't lost to time.